Okay, objective number 3 is multiplying and dividing rational expressions. So remember, when we multiply fractions, we just multiply straight across. So it's going to be the same thing with rational expressions, which means it's pretty much the exact same steps as we just did. We're going to factor numerator and denominator, or determine the domain, divide out common factors, and then put them all together. But remember, because it is all multiplication together, it all basically becomes one big fraction. So for 3a, if we have x squared plus 5x plus 6 over x squared plus x minus 6, this takes a little bit longer here because I have to write it. You don't. Squared minus x minus 6. Okay, so we're going to factor all four. So this one, two numbers that multiply to 6 and add to 5. So x plus 3, x plus 2. My denominator multiply to 6 but subtract to 1, so that's 3 and 2. So we want a positive 3 and minus 2. So we'll multiply negative 6 and 3 minus 2 is a positive 1. And multiply, so x squared minus 9 is the difference of squares. So we have x plus 3 times x minus 3. And x squared minus x minus 6. We want multiply to 6, subtract to negative 1. So this time we want an x minus 3 and a plus 2. Now from here, because we're multiplying, we can basically ignore this. We can just kind of make this all into one big fraction. But before we do any cancellation, we need to note the domain. So looking at the denominator, this one says x can't be equal to negative 3. This one says positive 2. This one is a positive 3, and this is a negative 2. So my x can't be positive or negative 3 or positive negative 2. Now we can start canceling. So we can put it all together and then cancel, or we can just cancel right here. So I have an x plus 3 in numerator and denominator, so those cancel. We have this x plus 2 and this x plus 2, so those cancel. We have an x minus 3 and x minus 3, so those cancel. And all we're left is an x plus 3 in the numerator and an x minus 2 in the denominator. Okay, so that's multiplication, pretty straightforward. Now division is basically the same, it's just a couple extra steps. So for 3b, let's say we have x squared plus x over x squared minus 4, and we're going to divide that by x squared minus 1 over x squared plus 5x plus 6. Okay, so before we do anything else, we're going to factor everything and figure out the domain before we do any kind of like keep change flip or cancellation. So if we go ahead and factor everything, if we factor the numerator here, we can just factor out the x, so it's x times x plus 1. The denominator here is a difference of squares, so x plus 2 and x minus 2. And we're dividing that. This is a difference of squares, so that becomes x plus 1, x minus 1. This denominator here, x squared plus 5x plus 6, so multiplies to 6, adds to 5, so it would be x plus 3 and an x plus 2. Okay, so looking at the domain. Okay, so we know we have to look at both denominators. So we know that x can't be equal to a negative 2 or positive 2. And it can't be a negative 3. And this also says negative 2. Now, because this is a division problem, remember we cannot divide by 0, which means that not only can the individual fractions not have a denominator of 0, but this whole thing can't be equal to 0 too. So we have to also set the numerator equal to 0 for our divisor here. So we also need to look at this one. X plus 1 and x minus 1 can't be equal to 0. So we know that x can't be equal to positive or negative 1 as well. Because either of these will make it undefined, and this one will make the entire thing 0, which means you're dividing by 0. So you have to set this, this, and that all equal to 0 to find your domain. Okay, from here, this is when you do the keep, change, flip, and then cancel. So the 2 extra steps, right? You have to set this one equal to 0 as well for domain, and then you have to keep, change, flip. So we keep this one, x plus 2, x minus 2, and then we change this to multiplication, and now we have an x plus 3, x plus 2 in the numerator, and x plus 1, x minus 1 in the denominator. And then it becomes just like the other one. We're going to just cancel everything that can be canceled. So we have an x plus 1 in both top and bottom, and we have an x plus 2 in the numerator and denominator, and then nothing else is repeating. So our final answer is x times x plus 3 over x minus 2 times x minus 1. And then you can either leave it like this, or you can actually multiply it back out to look like polynomials. That is up to you.